Next is Andy Everdale, Technical Director at Tangent, and Andy is going to be discussing unlocking sustainable system design. So if we could put our hands together and welcome Andy. Thank you.
Thanks. Hi, everybody. First of all, a little bit of a warning. I am in tech. If I shut my eyes, I can see the matrix. There's going to be boxes, there's going to be arrows and acronyms, but I'm going to do my best to explain these as I go along. So we talked a lot about digital transformation today, and you guys will have your own KPIs and North Star metrics you're aiming for. It's really important to consider sustainability as part of those KPIs. And today we're going to look at cloud emissions, sustainability in the cloud, and some techniques and tools you guys can use to monitor and measure it and reduce your carbon outputs. So to start off with, we're going to look at carbon emissions on a global scale. Now, there are four main polluters. It's traditional agriculture, industry, transport, and infrastructure. And if these guys don't sort their shit out, we are probably all doomed. But us as an industry, I'm going to take a bit of an assumption here that we're all working in digital because we're all part at the Digital Transformation Conference. We fall under the category ICT, Information Communications Technologies. Now that makes up things like our phones, our laptops, the internet, the clouds, and therefore data centers. Now data centers are the source of the problem for our industry. They need two things in huge abundance: power to run them, process all the data, and water to keep them cool. And as a result, they're having real-world impacts to local communities and the environment. Mike Berners-Lee, he's a professor at Lancaster University. He's the author of the books How Bad Are Bananas and The Carbon Footprint of Everything. He's also Tim Berners-Lee's brother. What a powerhouse of a family, right? Imagine being invited for Christmas dinner with those guys. He estimates that ICT makes up between 3 and 4% of global emissions in 2022. It's also worth noting, we've talked a lot about this today already, that internet usage and the use of technology is on the rise. Since 2012, we've seen steady increase in internet usage of between 4 and 12% continually every year, and that's not expected to slow down anytime soon. So if you look at ITC, and this is data from 2022, if you look at ITC, this is a 3-4% compared to transport, infrastructure, agriculture, and traditional industry. It's quite a small percentage, as I was saying before. However, the usage is on the rise. We know that there's additional technologies like blockchain and AI, and these technologies are going to come with a carbon overhead. It's also worth noting that these traditional industries are more focused now on becoming more efficient, and they're going to rely on technology to do that. So it's largely predicted, as we go through the next 5 to 10 years, ITC emissions will rise, where the traditional polluters' emissions will have to fall if we have any hope of hitting the target set out in the Paris Agreement, the 1.5 degrees Celsius. So we talked about data centers. I'm going to talk a little bit about cloud. Here are some of the cloud commitments from the 3 major cloud providers: Azure, AWS, and GCP. I'm not going to go through them piecemeal, but it's important to note they all have carbon neutrality targets, and it's normally through a series of offsetting or carbon credits. They also are looking at using renewable energies, becoming water positive, and having zero waste policies for their data centers. If you pick out some of these points to sort of just highlight, GCP, for example, Google's cloud platform, they were the first to become carbon neutral since 2007. Microsoft have committed to offsetting all the carbon Microsoft's ever produced since it was established in 1975 by 2050. So some key stats up here, and all of the cloud providers have some commitment to carbon and carbon usage. And as technical leaders or people running digital transformation projects, one of the major things you can do is a migration to the cloud. This will help solve a lot of the issues you have now with the carbon emissions of your systems compared to on-premise usage. Microsoft have even started looking at like innovative ways of hosting data centers under the sea, for example, to keep them cool. Our nearest data center hosted under the sea is in Scotland. It's in Faslane. I was at South by Southwest this year, and I heard someone from Virgin Orbit, although unfortunately they don't exist anymore, talk about data centers on the moon. So now there might be off-world backups on the moon by 2050. Some crazy stuff going out there by the technology providers to look at this problem. It's not all rosy, though. Carbon emissions actually rose from Microsoft in 2021 by 20%, or 14 million tons. This is largely down to the pandemic and the increase in everyone using Teams and all this kind of stuff had a real big impact on the environment. Even pre-2021, ITC's emissions were greater than the aircraft industry. So we have a real responsibility here as a collective group of people to start reporting and driving down our emissions. It's also worth noting that a lot of the cloud providers' focus is on water positivity, but they're not putting water back into the local communities affected. They're putting water back on a global scale. And if you look at the likes of the people living in Arizona or the people living in Ireland, much closer to home, and the impacts that data centers are having on their day-to-day lives, it's huge. Lastly, I think carbon emissions are on the rise for these providers, so we need to think about how we can reduce the carbon emissions of our systems. And we're going to talk about some techniques today, and this will get a little bit techie. So first of all, I'm going to tell you how the internet works, or how a website works in hopefully a basic way. You have a web page. That's going to be running on your laptop, right? It's going to be running in a browser. If that web page is bright, it's going to be using more power for your monitors. So now you can start to think about, from a design perspective, overlaying dark filters on it. If you look at likes of Boohoo, the fashion providers, they've started to do this recently. If you've got videos that are auto-playing, that's going to be downloading lots more information and playing these videos, which are huge files, which is going to be causing carbon impact. Maybe it's the number of images you've got. Maybe it's the number of fonts you've got. Maybe it's the fact you guys have got Hotjar or something running on it. It's a big JavaScript library that's loading up. All of this will have an impact on the environment. Now, I'm not saying you shouldn't be doing this, but I'm saying it needs to be considered, and you need to think about how you measure this and maybe how you offset this problem. So you're looking at a web page, you're looking at a browser in the UK. That's going to make multiple hops across the internet as well until it hits a web server. And that web server, traditionally, before edge computing, would be hosted in a particular part of the world. Now, in this case, for the example, I've used a web server in Denmark. So that's a relatively short hops, but every single hop across the internet will be producing CO2. The amount of data you're downloading from that web server as well, so the amount of images, the amount of fonts, the amount of video, etc., all has an impact. That web page as well that generates by this web server in Denmark, that might be using a CMS. It might be pulling information from a database. It might be pulling something from an API. All of this will have CO2 attached to it. And it will create some HTML and fire it back across the internet. That's how a web page works. There's CO2 all the way along that chain, and it's important for us to realize, this is a real-world thing, and it's having impact on the environment. Now, if you have users that are in the States or in China, that information has to travel a lot further, and that also has an impact on the environment. So this is how sort of traditional websites work, or monolithic applications work, and there's some problems there, right? You can see some issues. Firstly, it's performance. Cost could be an issue in the amount of work these servers are having to do, or CO2. So the good thing is, all those three things can be addressed by taking different architectural principles. We can reduce costs. Your cloud costs will be tied to the amount of work your servers have to do, or how much information you're passing through them. By taking certain architectural approaches, you can start to reduce those costs. You can also start to reduce the amount of carbon these particular items are producing, and increase users' performance. Now, I'm going to introduce you to something called static site generation, which is like a new toy for some of us techies. And there's some big providers out there, the likes of Vercel and Next and people like this. You may have heard of some of these guys. But this is slightly different. This is taking the MAC principle of architecture, which stands for microservices, APIs, cloud native, and headless. And we're looking at headless CMSs here. So you have a headless CMS. That means all the content from headless CMS is transferred via an API. You then statically produce those pages. So rather than producing the pages every time someone refreshes the browser, you produce them once when you make a publish change, or when you delete the page, or when you unpublish the page, or when your development team makes a change to that page. You're only generating the HTML once, which is much more efficient, right? That web page would then be stored on the cloud, and it would be stored in a CDN, which means it's being served locally to your users. The requests aren't having to travel all the way across the globe. They're going to be served from a server within London if I'm looking at a web page in London, for example. And that means lightning quick performance. It also means less strain on your downstream systems, which means cost benefits and savings. And it also significantly reduces the amount of carbon these systems are producing. The user still looks at a web page. Nothing's changed there, still through a browser. For anything we can't statically generate, say, for example, your share price, you can statically generate that because it's going to change all the time. We can make asynchronous requests to APIs and pull these things in parallel. So that's static site generation in a nutshell. Now, we implemented this for UK Power Networks. They are an infrastructure provider for the southeast and London. They keep the power on for 8 million homes, and during events like storms, like today with Babette, I think it's called, they get large numbers of users going onto the website because there's people reporting power cuts. We did a digital transformation for them, taking them from Sitecore and moving them to a headless platform called Umbrico Hardcore, and here are some of the benefits or the results. Firstly, performance. Time to load the home page dropped from 4.22 seconds to 1.41 seconds. That's significant, right? That will affect their SEO rankings, that will affect the user performance and user satisfaction of the pages. This time as well also is global. So if somebody in China looks at that page, it'll be the same as somebody looking at it in the UK. So there's like significant benefits there from a performance perspective. Secondly was scalability. The old Sitecore application used to fall over around 5,000 concurrent users. A concurrent user is doing something in a particular millisecond in time. We can now handle 40,000 concurrent users plus. And to put that into perspective, google.co.uk, the search button, that has about 30,000 concurrent clicks. So about 30,000 clicks per millisecond. Cost-wise, Sitecore is expensive. There was a lot of expensive infrastructure about it. Now we're relying on CDNs, which are relatively cheap in comparison. We saved 66.61% of OpEx costs just by taking this approach and taking down the reliance on cloud infrastructure. And lastly, carbon. So the old homepage used to produce 1.44 grams of carbon. The new approach produces 0.22 grams of carbon. Now, to put that into perspective, do you guys remember Storm Eunice? It was when the Millennium Dome roof came off. 3.2 million people hit the site in 2 days. The homepage carbon saved by this approach was the same as 9 flights from London to Copenhagen in one weekend. And most users were hitting 3 or 4 pages. So actually, when you start to look at that over the full journey of the site, that's significant carbon saved. Next, it's important to consider reporting. And at Tangent, we offer a bunch of reporting services, but you guys should start to look at your reporting. You need to know how much carbon your systems are producing. There's free open source tools out there, like the cloud carbon footprint dashboards, that you can put into your cloud spend and start to look at the decisions you guys are making as digital leaders and how much carbon they're producing and what effect they're having on the environment. You should be setting yourselves KPIs about making digital change that brings down carbon, doesn't bring it up. My name's Andy Everdale. If you're interested in this, I can show you some of the dashboards outside, or you can add me on LinkedIn and we can have a bit more of a chat. And we've also wrote a white paper on the subject that looks at composable architectures, the benefits from a marketing perspective, an operation perspective, and a technical perspective. If you're interested, there's a QR code there and you can download the report. Thank you very much. Cheers.